Hello everyone, I am your friend Shadab Imam and today we are going to see a typical problem on network construction. So please watch this video till the end, and if you are new to the channel, please subscribe the channel and don't forget to hit the bell icon. So let us see what the question is. The question says that a batch of 4 axles is to be processed on the following 3 machines in the sequence lathe, milling and grinding. Instead of working on these 4 axles, first on lathe, then on milling and finally on grinding, in this sequence it is desired to process the first axle on the lathe, and as and when it is processed, it is taken up on milling and the second axle on the lathe, and so on. In other words, each of the 3 activities, lathe, milling and grinding, have been quartered for the sake of concurrent operations. Draw the network for the problem. So in this particular problem, it says that there are 4 axles which need to be processed on 3 machines in the sequence of lathe, milling and grinding. But instead of taking a sequence where all the 4 axles are first processed on lathe, then all the 4 axles are processed on milling and then grinding, rather than taking this sequence, what we desire is to take the first axle and do lathe operation, and as and when it is completed, we will take the first axle to the milling and the second axle to the lathe. So there are concurrent operations of lathe and milling carried out simultaneously. Similarly, as the second is completed on milling, it has been transferred to grinding, and the second as completed on lathe has been transferred to milling. So this sequence has to be followed. So let us first see what we need to do to construct a network diagram. First we need to find the precedence. So I have already prepared a table where we have certain activities. That means we will operate all the 4 axles on lathe, milling and grinding. So L1, L2, L3, L4 are lathe operations on 4 axles. Similarly, M1, M2, M3, M4 are milling operation on 4 axles, and G1, G2, G3, G4 are grinding operations on 4 axles. So we need to find out the precedence it follows. So when we realize that when the first axle is processed on lathe, there is no precedence. That means lathe machine is empty and the first axle can directly be fed or processed into lathe machine. So this has no precedence. Now to process the second axle on lathe machine, it is required that the lathe machine is free. Now to have that requirement, the first axle should be processed or should be completed processing on lathe machine. So the second axle on lathe machine can preceded by the processing of first axle on lathe machine. That means the lathe machine operation for second axle can only be started when the first processing of first axle on lathe machine is completed. Similarly, we can see that the third axle can be processed on lathe machine only when the second axle has been completed. Similarly, the fourth axle can be started processing on lathe machine when the third axle has been completed. Now moving on to milling machine. So the first axle on milling machine. So the requirement to process the first axle on milling machine is that the lathe operation on the first axle has to be completed. So that means the activity L1 has to be completed here. So we can see this is L1, and the milling machine, which is currently free because no process has been started in milling machine. So we can see that the only precedence it has is L1. That means operation M1 can be started when L1 is completed. That means the processing of first Excel on lathe 1 is completed and it can immediately be transferred to milling operation. Now the milling operation of second Excel can be started when the lathe operation on second Excel is completed, and meanwhile at the same time the milling machine which is currently processing the Excel 1 has also should also be free. So there are two precedents, or it is preceded by two activities. First is that the lathe operation on second Excel has to be completed, and along with this the machine has to be free. That means milling machine is currently doing milling operation of first Excel. So when this is completed and this is completed, then only the second Excel can be processed on milling machine. Now similarly, the third Excel can be processed on milling machine when the third Excel is completed on lathe machine, and simultaneously when the milling machine is free, which is currently processing the second Excel. So along with this it has a precedence of M2. Now similar is the case with fourth Excel on milling machine. That means lathe operation on fourth Excel has to be completed, and along with this the milling operation of the third Excel needs to be completed. After completion of these two, we can start milling operation on fourth Excel. Now coming to grinding. For grinding of the first Excel, we need to have finished the milling operation of the milling operation of the first Excel. Okay, so we need to complete the milling operation of the first Excel, and grinding machine right now is free because no operation has been started on grinding machine. So the only precedence it has is M1. That means as soon as milling operation on first Excel is completed, we can start grinding operation on first Excel. Now grinding operation on second Excel, we need to complete the milling operation of second Excel as well as grinding operation for first Excel, because we can only start processing of Excel 2 when the milling process is completed, as well as at the same point of time the grinding machine has to be free. That means the grinding processing the first Excel has to be completed. Now similarly, grinding operation for the third Excel can be completed when milling operation of third Excel is completed, and along with this the grinding operation of the second Excel has to be completed, so that the grinding machine will also be free and Excel 3 is also free. Now moving on to grinding on Excel 4. For this, milling on Excel 4 has to be completed, and along with this grinding on Excel 3 is to be completed. So now we have established a precedence for all these activities. Now let us start drawing the network here. So we will see which are the unpreceded activities. So we can see that activity L1 is the only unpreceded activity here. So we will start this from the starting node. Suppose this is the starting node and this is activity L1. Now moving on to activity L2. L2 is preceded by L1. That means as soon as L1 is completed, activity L2 can be started. Now similarly L3 can be started when L2 is completed. So, and one more thing, we need to see the other precedence also. So because this is preceded by L2 and this M2 is preceded by L2 and M1, that means there will be a dummy activity here, but dummy activity will not lie for this, because this has been directly preceded, L3 is directly preceded by L2 only. So we can start as the activity L2 is completed, we can start activity L3. Similarly, L4 is preceded by L3. So as L3 is completed, activity L4 can be started. Now moving on to M1. M1 is preceded by L1 only. So we can see that at this node we can see only activity L1 is completed. So we can start activity M1 from here. So this is activity M1. Now moving on to M2. M2 is preceded by activity M1 and L2. Now here what we need to have is, we need to draw a dummy activity here, because if we end M1 here, we cannot directly join this M1 to L2, because this will violate the rules for network construction. And if we look closely, we can see that this M2 is preceded by L2 and M1, and G1 is also preceded by M1. That means surely there will be a dummy activity here. So first of all, we will terminate this activity M1, and we can see that G1 can be directly started from this activity, and to draw activity M2 we need to have a dummy activity. So we will draw a dummy activity to a new node. This is DM1. We have drawn a dummy activity to the new node, and we will again draw a dummy activity from L2 here. This is DM2. Now at this particular node, activity M1 is completed as well as activity L2 is completed. So M1 and L2 is completed, we can start activity M2. So we will start activity M2 here. Now the question comes to my mind that why I have not drawn the dummy activity directly between these two nodes, because at this particular node we can see that it is preceded by only activity L2, and if we draw a dummy activity between these two nodes, that means now this node will have a precedence of L2 as well as M1, which will violate the condition for this activity L3, because L3 has been preceded by L2 only. So because it is preceded by L2 only, we cannot draw a dummy activity of M1 coming to this node. That's why we need to draw two dummy activities here, so that L1 can show precedence alone with L3, as well as L2 can show precedence alone with L3, as well as it can show precedence with M1 here. So I hope it is clear now why we have not taken the dummy activity directly to this node. Now as M2 is drawn, now moving on to activity M3. For M3 it is preceded by L3 and M2, and now we can see that here M3 is preceded by L3 and M2, and G2 is preceded by M2 and G1. Because M2 is has precedence with L3 as well as with G1, we need to draw two dummy activities again. So we will end this here, and we will draw two dummy activities. First will be here, this is DM3 dummy activity 3, and the second will be for G1, which will be downward somewhere when we draw DM4. Now for M3 it is between L3 and M2. So we will draw another dummy activity from L3. This is DM5, dummy activity number 5. So at this particular node, we can see that activity L3 has been completed and activity M2 has been completed. So we can start activity M3 from here. So we will start activity M3 from here. And now moving on to activity M4, we can see that it is preceded by L4 and M3. And as we can see here, M3 has precedence with L4, and for G3, M3 has precedence with G2. So here also we will require to have two dummy activities. So again what we will do here is we will terminate this and we will draw a dummy activity here. This is DM6 and a dummy activity downwards for the activity G2. This is DM7. Now to draw M4, we need to have L4 completed and M3 completed. So we will bring L4 here. So we can see that at this particular node, activity L4 is completed as well as activity M3 is completed. So for this point, we can start activity M4 here. So we have started activity M4. Now moving here, we can see that G1 activity is preceded by M1 only. So here we have the node where it is preceded by activity M1 only. So we can start directly activity G1 here, because G1 is preceded by only M1. So and this node shows the precedence where M1 only is preceded. Now moving to activity G2, it is preceded by M2 and G1. So it will have, we already have drawn the dummy activity from M2 and this is activity G1. So we will converge these two activities, and at this particular node we can see that activity G1 and activity M2 is completed. So we can start activity G2 here. So activity G2 has been started. Now moving on to G3, activity M3 and G2 needs to be completed. So activity M3, we have already drawn a dummy activity here, and this is G2. So we will converge this, and at this particular node we can see that activity M3 and activity G2 is completed. So we can start activity G3 from this particular node. Now moving on to activity G4, activity M4 and G3 has to be completed. Activity M4 and G3 has to be completed. So we will converge these two to a common node, and this will be our terminal node. So we can see that now as our activities has been finished and there are no open activities, so this is our required network where activity G4 is here. Sorry, this is activity G4, and once the activities are finished, we can see that there is only one open activity. So we will terminate this activity to the final or the terminal node. So this completes our network, and now we will start naming the events. So we have already seen how we name the events according to the Fulkerson rule. So first of all, we will name the starting event as 1, and now we will delete all the outgoing arrows from this event. So this will be the new initial event, and this will be numbered as 2. Now from here we will delete all the outgoing arrows from the numbered event, that is from 1 and 2. We will delete this, and because of this we have 2 new initial events. So this will be 3 and 4. Now again we will delete all the outgoing arrows from the numbered event, and we can see that there are again two initial events. So this will be 5 and 6, and again we will delete all the outgoing arrows from the numbered event. We can see that this will be 7. Again we will delete, so this will be 8, this will be 9. Again we will delete all the outgoing arrows from the numbered event. So we will have new initial event here, so this will be 10. Again if we delete, this will be 11, this will be 12. Again if we delete, this will be 13, and this will be the final or the terminal node 14. So this completes our network diagram. I hope if you like I hope you understand the lecture. If you like this lecture, please share the lecture. Have a nice day. Thank you.